Question number 2 is fun because we've already done all the hard work, and it's just really a matter of reading the question. It's going to be really fun. Let's take a look. Using the probability values you already completed in part 1E, find the following probabilities rounding to 3 decimal places. It says the probability that a household has exactly 4 dogs. Okay, exactly 4 dogs. We're going to be looking at a lot of vocabulary. So we're going to look at the probability. This is a sentence, obviously, right? This is how it would look without a sentence. This is the mathematical statement. So in a sense, we're helping you build your mathematical vocabulary by giving you the sentence in front. But these two things, this is the same as this. They're the same exact question. They're not asking you two different things. Let's go back and take a look at the probability of 4 dogs. So I'm looking at our table and we're looking at 4 dogs, which is here. And remember, our probability is in this row. Ready? Let's answer these questions. The probability of exactly 4 dogs is 0.0133. And this is from the table. Let's go ahead and change. I just realized this is 3 decimal places. Let's change it to 4. We had already rounded once, so it's not okay to round again. If we had 3 values since the beginning, then we would have 3 values here. But we shouldn't round twice. That would be inaccurate. So let's keep it at 4 places. B, the probability that a household has exactly 2 dogs. Exactly 2 dogs. We're looking at the probability of 2, and you just go and look at the table, and it says 2 is the probability is 0.772. Now, is this a high probability? Not quite, right? You're going to go to the house, knock on a door, and there's only going to be 168 households out of 2,000 that tell you that they have 2 dogs. It's not very likely. Well, in this neighborhood, at least, the one that's in our survey. The probability that a household has more than 5 dogs. Okay, this is where it starts getting interesting. A and B was baby steps. Taking a look at our vocabulary, did anybody survey a household with what is more than 5 dogs? 6 dogs, or 7, or 8, or 9, right? How many households have more than 5 dogs? None. Right? Because we do not have a value for that. Let's try D. The probability that a household has between 2 and 4 dogs, not inclusive. This is important. Remember that the words are the same as this. So if you'd rather look at math, the mathematical statement, look at this part. If you'd rather look at the sentence, then look at the sentence. Not inclusive. It does not include the 2 and does not include the 4. So what is between 2 and 4? 3 dogs. The probability of 3. Looking good. E, the probability that a household has between 2 and 4 dogs, inclusive. This time it's different. This time we're including it. So let's still look at these keywords between 2 and 4, inclusive. How many dogs? 2 and 3 and 4. This one's so different from all of the other ones. Let's take a close look. We need to include the probability of 2 and the probability of 3 and the probability of 4. The probability of 2. Probability of 3. probability of 4. Let's put these together. Beautiful. All right, you're going to try F, G, and H. Pay attention to the keywords such as 6 or less, and then tell me, write out how many dogs it would be so that you can go and find the probabilities. Don't try to do it in your head, write it out, and it's always the best way. Let's try I. The probability that a household has more than 3 dogs. What is more than 3? Has to be more than 3. Is 3 more than 3? No. So it starts at 4 dogs and then 5 dogs. We don't have any more on the survey, so we would have the probability of 4 plus the probability of 5, and that gives us, let's add these up. The probability that a household does not have more than 3 dogs. This one is beautiful. And so you see this mathematical statement looks so different than the sentence and so different than all of the other examples that we've tried. So I really enjoy this example. More than 3 dogs away from the overall probability, which is always 1. We're going to have 1 minus, and then what are the numbers not more than 3 dogs? Not more than 3 dogs are going to be the probability of not more than 3. So does it include 3? Yes. 3 is not more than 3, so it includes 3. It's going to include 2. It's going to include 1. And it's going to include 0. So we need to add up the 3, the 2, the 1, and the 0 before we can subtract it from 1. So let's find these values. We have 1 minus, and then probability of 3 is 0.0221 plus 0.0772 plus 0.194 plus 0.6855. Let's put these together. And last up, let's subtract. And we are all done there. Our last question is which values have above or equal? And actually, these should be the same. There's a little bit of a rounding area, but if you notice, compared to everything else, they're very similar. I'm going to tell you there's a rounding error here. They don't end up exactly the same because of our initial rounding, but what I do want to point out is the probability of not having more than 3 dogs is the same as a probability that has more than 3 dogs, okay? These are the same. I and J have the same values. So why are I and J the same value? I want to show you that P of 0 plus P of 1 all the way through the P of 5 is going to be equal to 1. They should all be equal to 1. All the probabilities are always equal to 1. And if I wanted to say the probability that a household does not have more than 3 dogs, I'm taking away these values here. So remember math, so I'm doing 1 minus this takeaway, right? Math works the other way as well. So if I took that away, what's left? This is what's left. And so what I could have done is instead of doing the takeaway, I just see what's left. And if you look at part I is what's left. Part J is the other way, is taking away. Therefore, they're the same thing.